Hi everyone, this is a Major League Baseball problem. A Major League Baseball diamond is square 90 feet on each side, so all of this is 90 here. It's 90 feet all the way around. Alright, the pitching rubber is right here, and it is located 60.5 feet from home plate and second base. On a line joint home plate and second base. So basically I have to find out how far is the pitching rubber to first base. So that's your X. And how far it is to second base. So that's we're gonna look for Y. And if he faces home plate, how far does he have to turn, or what angle does he have to turn through to find to face first base? And that is going to be our beta. Okay, so the first thing we're going to do is A, and we're going to find X. So how far? We have a side, angle, side, triangle here, so we're going to use the law of cosines. And we have that we're going to let x squared, since we're calling this x, equal 60.5 squared plus 90 squared minus 2 times 60.5 times 90 cos of 45 degrees, which is square root of 2 over 2. And then I'm going to go and combine these. I'm going to go and simplify this part and then simplify this part. And I'm going to take it in 2 steps and go ahead and do it under the radical sign. So I'm square rooting both sides here. So we get 11,760.25 minus 5,445 cos of 45. So you can write cos of 45, or you can just write square root of 2. What I did is I went ahead and divided this out by the square root of 2, and I used this instead. So basically this was 2 times that. Alright, so, or you can just put this whole thing in the calculator if you're really good at the calculator, and you will get approximately 63.7 feet. So that's your X, and I'll put it right here. 63.7 feet. Now, to find Y, we have the Y is going to be also from base to second is going to be, we're just going to use the Pythagorean Theorem, okay, because this is a right triangle here. So if we use the Pythagorean Theorem, we're going to get 90 squared plus 90 squared equals my C. So C squared. So that's going to be basically 60.5 plus Y. I'm going to add the Y here. Okay, so basically I'm doing this whole triangle here. Basically it's not this right triangle part here. I'm sorry about that. It's basically I'm using this one. So let me put it in purple. I'm taking this whole triangle. So that's in purple. So this is your A, this is your B, and this whole thing here would be your C. All right, so we're going to go ahead and take care of that, and we get 16,200 equals 60.5 plus y squared, all right? And if I square root both sides, I'm going to get 60 square root of 16,200 equals 60.5 plus y. So basically what I did is I just squared root both sides. And that canceled this out. Alright, so y equals the square root of 16,200 and then minus your 60.5 to solve for y. And that's going to give you y equals there's approximately 66.8 feet. So y is 66.8 feet. Now we have to find the angle. And so the way we do that is we're going to find b by using the law of cosines again. So we have all our information, and we're going to use law of cosines to find b. So cosine of beta equals 60.5 squared plus 63.7 squared minus 90 squared over 2 times 60.5 times 63.7, which is negative 382.06 over 7,707.7. Then to find the beta, and just not the ratio, we get negative 382.06 over 7,707.7, and this yields 92.8 degrees. So the picture needs to turn an angle of about 92.8 degrees to face first base. And I'm going ahead and, in case you're unaware, remember the formula for this is going to be a squared plus c squared minus b squared over 2ac. That's just a rewrite of the law of cosines. Okay, so that's all. Have a nice day. Bye-bye.